This is the Amp Hour Podcast, released April 2nd, 2023. Episode 626. Intelligent Routing with Sergiy Nesterenko. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hey, it's Sergiy Nesterenko, the CEO at Quilter.ai. We're building a generative AI for PCB design.
Hey, Sergiy, how are you?
I'm doing great, Chris. Thanks for having me. Excited to be here.
Of course. Yeah, and obviously, AI is a topic that is, well, we can't help ourselves. Our last show, we went back to it like 3 or 4 times. It was actually not in a PCB context, but right before we started recording, I'm like, oh, Dave was just posting about an AI solution as well, and we're going to be talking another one here. I'd love to get an overview because when I was introduced to you, I had a different thing in my mind than kind of how you guys operate. So I'd love to kind of get an overview so other people have that as a upfront of like, what is the AI piece of all this?
Gotcha. Yeah, so our ultimate goal is to start with circuit schematics and then output a ready-to-go PCB. So the idea is that you should be able to kind of extract all the information you need that defines what the circuit board needs to do out of the circuit schematic. And then to create a PCB that is kind of manufacturable, verified for physics, verified for DRC, so on and so forth, automatically. So the analogy I like to use for this is kind of what we have in software, which is a compiler. In software engineering, you write some Python or some C, you click a button, and ones and zeros come out that run on your processor. We want to achieve the equivalent for PCBs.
Yeah, that's a good idea there. I mean, it does seem like there is like kind of always the black box aspect. I think when we were introduced, I was thinking it was going to be like the design side. So I was like, well, I don't want, some AI engine to pick our resistors for me and hook stuff up in a schematic. So it's still like when you and I talked last, the one thing that kind of stuck out to my mind, it was like, it's kind of like a supplemental layout engine on top of the things that I've already designed. Is that a fair assessment?
Yeah, that's absolutely fair. So the way that we operate, if you have done some part of the layout yourself, like say you have some circuit you really, really care about laying out yourself, we don't touch it. We just go around it and finish everything else. But also we should be capable of starting from scratch, right? So the kind of boards that we've built in the past, we've had both cases, right? We've had a customer where they really, really cared about certain parts of their layout, so they did it on their own. We finished the rest. And the boards that we kind of develop ourselves, to test the software and make sure it actually works, we do entirely from scratch. So what we kind of take as an input is some of the constraints. So for example, perhaps it's important to define like the size of your board for mechanical constraints, maybe the placement of some connectors or some, cameras or whatever else. That's kind of like, part of the mechanical logic, not the circuit logic. But then there's a whole bunch of like ICs, capacitors and resistors and traces and all that stuff that like doesn't really matter where it goes. It just matters that it works. And so that's kind of what we're focused on is like everything that you left up to us. The constraint is it has to work, not it has to go in a certain place.
Got it. Yeah. And that kind of, I feel like a lot of the fear mongering around AI is like it's going to do everything for you. But the thing that we've talked about on the show in the past is kind of like this supplemental kind of co-design piece where I am nearly certain over time it will take on more and more of the design pieces, suggest things that are novel that I wouldn't have thought of, or check stuff. But really, it is that side by side where I'm doing some of it, the engine's doing some of it, and it's really just kind of speeding up a workflow.
Yeah, I mean, this is going to be an interesting direction for us to kind of consider as we build the company out, right? Like whether you do a side-by-side co-pilot kind of thing or you do the whole thing from scratch, in either case, you need a really good, layout engine, you need a really good router, you need to be able to consider the physics of the board, so on and so forth.
Right.
It's really just a matter of kind of like the user experience and like what controls you give to the user.
Yeah.
One of the things that we are kind of trying to be mindful of is that a lot of the previous kind of routers and placements that have existed in the past have required a lot of configuration to get working. And a lot of people basically just say, you know what, I'm not going to learn how to configure these 18 million different settings and buttons and whatever. I'm just going to lay it out because I know how to do that.
Got it.
And so that's something we're trying to be mindful of is like, how can we get the design intent from the schematic, from knowledge of what chips you're using, so on and so forth, and make those decisions for you if you don't want to.
Yeah, that's good. And I do think that, like, much like I have ERC or error rules checking and a DRC for design rules checking, like that is something that's already built in. That's a rules engine. What does the rules engine look like now? So now I get to a certain point in a schematic, or I've got, maybe, let's say I'm 10 or 20% done with my layout with the important parts done. What do I get to then configure on Quilter?
So we're going to be progressing this over time, of course. At the moment,
Hmm.
it's just the very, very simplest things, right? So I don't want to give the
Okay,
impression that like, hey, this thing's
sure.
done. Go build a motherboard or an
Yeah,
iPhone
I
with
see.
it,
I
right?
see.
Like
Yeah,
we'll,
and I
we'll
guess we
get
should
there.
say how old is the company? It's pretty new, right?
Yeah, yeah. We pivoted to PCB design a little over 2 years ago,
Okay.
so fairly new. Most of the team that's currently with Coulter joined within the last year.
What were you doing prior to that?
Oh, prior to that, when we started the company, we thought about designing low cost sensors for manufacturing, just based on some previous experience I had in the field.
Uh huh.
Pivoted to trying to make software to process that data. Landed with a kind of a chicken and egg problem that, like, companies don't want to share data unless you can prove you can do something useful with it, but you can't prove something useful unless you have the data.
Uh huh.
And then basically went back to the drawing board, thought about it a little bit. I reflected back on my experience at SpaceX and kind of seeing the PCB layout problem bite us, and then pivoted to that. So that was about 6 8 months.
What was the if you don't mind sharing the PCB problem at SpaceX or other companies? What is the problem that you saw?
I mean, there's a number of problems with layout that we ran into. So, I mean, first things first, like, I first thought about this whole concept of doing this autonomously when I first started at SpaceX in 2014, right? First time that I designed a PCB, I needed to design one for some test engineering setup. And, it took me a while, probably a couple of weeks to like really learn. I was Altium at the time and learn how to do the layout and, just even how to drive the software and everything. And as I was doing it, the whole time I was thinking, like, why isn't a computer doing this? Like, this seems like something a computer should do. Of course, I learned computers are not very good at doing this at that point, and frankly, they still aren't. But there's a bunch of problems that kind of come up, right? So for one, it's time consuming, especially for a beginner or even intermediate. PCB layout can be days, weeks, or even months on a complicated project. That's a bottleneck. That means that whatever product you're building, whether it's an internal tool or an actual product that is going to fly, you're not finding out whether the thing works or not in real life for that much longer. And the other thing that happened in SpaceX a lot is that PCBs were kind of the tail end of the design, right? Like, so say you're making an engine controller, you first figure out, what actuators you're going to have, what sensors you're going to have, what the mechanical constraints are, so on and so forth. And the PCB kind of starts to come closer to the end, which means it becomes a critical path item. And in an Elon company, that's not where you want to be.
I mean, these days I don't want to be anywhere near an Elon company. If you just speaking for myself here, guys, bag of cats.
Fair, fair enough, fair enough. Yeah, so obviously, kind of like the latency from design to implementation is one issue. The other issue, of course, is that sometimes you don't get the design right, right? With software, you click a button, compile, run the code. Usually within a minute or two, if it's working or not.
Yeah.
With a
Right.
PCB, you're not completely sure, right? Designers kind of follow rules they've learned over the years about like what a good layout is and how to
Yep.
avoid, signal integrity issues and, power instability and all these things. But like ultimately there's not a quantifiable, rigorous way, short of going really crazy with simulations, to know whether this thing will work or not. People typically just build it and find out.
Right. Right. Yeah, and I think there's like kind of general guidelines around like how much do you need to care, right? When I think about like
Right.
low speed designs, I'm below 10 megahertz on everything. It's like I could probably I could do 50,000 vias and route the trace between all those vias, and it would probably still be fine. It would take a while. It'd be fine though, right? I mean, like it would,
100%.
it's just like these low and slow signals. It doesn't matter. But then, how do you also communicate that to people not already in that space and knowing when you need to care about these things?
Exactly. Yeah, that's actually a big issue for us for sure. I think as engineers, I mean, on top of kind of wanting to avoid any kind of rework, your brain kind of works like an optimization engine, right? Like if you see something that
Yeah.
isn't
Yep.
as good as it could be, you're kind of like, oh, that bothers me. And you
Yep.
go and try to fix it, even if it's
Right.
not strictly necessary.
Right. And then that balances against cost and time constraints, like you mentioned, like
That's
you were
right.
critical path, right? And so then there's safety constraints in a SpaceX style application. There's,
Yep.
like how do you balance all of these different things? What are the sliders that you need to slide?
Yeah. I mean, that is exactly the question and the problem. So yeah, I mean, frankly speaking, designing a company at a board, I mean, short of like the most critical boards that actually get a lot of attention from like the EMI team and the power team and so on and so forth, majority of boards are not that. Majority of boards are support boards or test boards or prototype
Right.
boards or some sort of de-risking. And like realistically, the answer is just build it and see what
Yeah.
happens.
Yep. Yep. F around and find out.
Yeah, exactly. That's pretty much it.
Okay. And so that's an interesting, yeah, that's an interesting kind of lead back to what you are talking about here. And so another thing I'd asked you when we first talked about this was just like, what is the scale and scope of you hope to achieve? And you'd mentioned that a lot of the boards that you think Quilter brings value to right now are not those super high end, super crazy boards because you still want humans in the loop. This is more like I need to connect this 20 pin connector to this 50 pin connector, just do the connections for me. That's something like that. Is that a fair assessment?
Yeah, that's pretty fair. So obviously our goal is to be able to cover everything in the long term, right? Like I think for me the holy
Sure,
grail
sure.
is to like do like a video card or something crazy like that one day. And certainly we can't, right? If Coulter tried to do that, I'm pretty confident the board would.
I mean, you should do it just to see, like you could have. I mean, and that's the other thing. Programmatically, you could have benchmarks over time. I look at like how
Yeah,
Midjourney has been improving, and like the same prompt from V1 up to V5. It's striking. It's really striking.
absolutely. Yeah, and so then the more interesting question is, well, what can we already do? So we have a number of boards that we've designed, kind of fully autonomously like this, where basically you have the schematic, we still leave the footprints up to the user. Especially at a big company, you typically have your own footprint library, and we wouldn't want to mess with that. But as far as the inputs that we take, like kind of said earlier, we'll take the board outline, the footprints, the net list already loaded, and like a handful of components pre-placed where you really care about their placement, and then we'll do the rest. And so we've done a number of boards like this, and the kinds of boards we've done. I mean, I think the most interesting one that we've done is actually an open source board called OpenMV. It's a computer vision board. I'm not sure if you're familiar with it.
Yeah, yeah. Quabana.
STM32 microprocessor. Yeah, it's fantastic.
Yeah.
So we built our own version of the H7R2, and yeah, I mean, put it together and it works, right? We were able to load a simple little program on it that does some face tracking,
Hmm.
puts it onto a screen, all on board, and then for a little bit of fun, we load a mustache from the SD card and put it on your face.
Awesome.
Had to do
Yeah,
that.
that's like in the Silicon Valley thing, right? Where
Exactly.
he works on that
Yep.
startup that does that. Yeah, yeah.
Yeah. I'm glad you got the reference.
Yeah, okay, great. We're on the same page.
So I think that like I agree that like in general, probably the most useful space for Quilter right now is like, hey, I've got 1,000 or 2,000 pins to connect. All of them are sub 100 megahertz. All of them are sub 2 amps, and I just need to hook it all up and get it working. We've done boards like that for sure, kind of like test engineering boards. But we are trying to push a little bit on the kind of physicsy things, right? So the OpenMV is, I mean, it's not like you don't have RF signals on there. You don't have to do any kind of crazy impedance match or anything like that. But still, it's not a ridiculously low speed board, right? It's reading from the SD card at 100 megabits.
It's an M7, right? I mean, there's high end components on there. Well, high end,
Absolutely. Right. Yeah.
powerful micros.
Right. Not a Core i7, but still a fairly
Yeah,
powerful
right.
micro. The camera's, decent resolution with addition speed,
Yeah.
all that stuff. And that all works great.
It'd almost be kind of interesting if you could, if you had like a measure for how long, like a benchmark for how long it would take a mid-career layout engineer to do a certain board,
Mm-hmm.
because then you could like start to give costs to these sort of things. Like I would imagine an OpenMV board would be, week to month kind of late range, whereas like you said, like an i7 to a mid-range engineer is probably months, multiple
Yeah.
months to, like depending on skill level and reference designs and everything else. But like starting from scratch on these things, like what are the, how do you really benchmark what is possible?
Yeah. Yeah. It's a great point. So we have obviously we have a full-time AE on staff. He's
Mhm.
kind of more of a late career engineer. He's been building boards for well over 20 years, so pretty darn experienced. I think he knocked out the OpenMV. Now, granted, the OpenMV design we did it at lower density than the original one. So,
Okay, sure,
we'll
sure.
have to up the ability to do kind of higher density boards. But for the one that we have on the site right now, it's definitely lower density than the one that's in production. But I
Got
think
it.
it took
Got it.
him maybe like he redid that layout in maybe a day or two. something like
Uh-huh.
that. It wasn't too bad. The software completes it in under an
Right, right.
hour.
Wow. Okay.
So I think the most impressive comparisons we've done were at boards that unfortunately I can't talk as much about because they're for customers, but boards
Yeah,
that take
yeah.
like 2 to 4 engineer days that we were again able to do in about an hour.
Oh wow. Okay. Yeah. So another thing that you had mentioned when we talked last was that you're kind of doing multiple iterations. You're not doing this like
Mhm.
on screen, someone watching it. It's more like I send the files up to the cloud. It's done in parallel, many different iterations, and then a result is sent to me. Is that right?
That's correct.
Yeah. So that does feel different because it's also getting that parallel processing side of things that I wouldn't get if I was like watching the traces happen, like I think Dave was doing in his recent AI review video.
Sure, sure. Yeah, I mean, I'd like to put something where you can kind of watch it think. I think that'd be super fun. It's not something that made the kind of MVP list in terms of like the minimum things we had to build to get something useful out there. But I think it'd
Yeah,
be
sure,
cool. Like
sure.
it's definitely very fun to watch.
Sounds like a good intern project, put it in
I
the
like it. Yep, yep.
Yeah,
Um,
yeah.
for sure. But yeah, we do send it off to a cluster, and we do use a fairly large compute cluster to generate a lot of variants. And part of that is just to give us a higher chance of actually getting a board back that's fully completed and passing all the DRCs. And a part of
Yeah.
it is just kind of allowing us to experiment on our end, right? Like we have a
Yeah.
lot of different algorithms that we're prototyping that approach this problem from different angles. And like if we push one that's good on one kind of board but not so good on another kind of board, then a different one picks up the slack, and it kind of just allows
Yeah.
us to throw the gamut at it as we experiment.
Yeah. It does sound kind of, it's almost like this is approaching more like place and route inside of an FPGA where you have timing constraints, you have all these things, all of these design files that you import to the place and route machine. Like I don't complain, well, I don't do FPGA anymore, but when I was doing FPGA stuff, I didn't complain that I didn't get to do like the logic level
Yeah.
drawing inside, Cordis 2 anymore. It was like, oh, place and route is going to do that, and it's going to have an output report of all the things that it does. And then they also had started doing that same thing where you could send it off to a cluster to get faster turn times because it's very compute intensive to run all these different diagrams and all these different timing path runs
Yep.
basically.
Yeah, exactly. And that's kind of the nice part about basically compiling some Verilog or VHDL, right? Is you don't like if the timing passes on the report and all the other checks pass, you're good to go. Like it's gonna work. I mean,
Yeah.
maybe in
Yep.
some really obscure case, there's something that might happen that goes wrong. But personally, I've never seen that, and that's where
Yeah.
we need to get to with PCB design.
I think one of the key variations is just how visual PCB layout is.
Mm-hmm.
Like even to the point where you can see traces on the top of the design. And
Mm-hmm.
I did want to call that out because we talked about that before we started recording. Like you have 4 of these designs on the blog,
Mm-hmm.
and people are going to look at this and be like, "Wait, what?"
Yes.
So why don't you give us a little word picture of what the traces look like right now, and then how that all kind of plays together?
Basically, what people are used to in typical boards are what's called octilinear traces. So they're traces that go up, down, left, right, and 45 degrees, right? And that's how pretty much every ECAD software defaults when you do traces. That's how they're kind of made. That is not actually a constraint that's important for manufacturability or physics, right? Like you obviously want to avoid right angles to not have RF reflections and whatnot, but like 45-degree mitered edges are quote unquote good enough, unless you're doing something really, really
Mm-hmm.
crazy.
Yep.
Actually, you'll even see that when you do a really high speed trace, like an antenna or some DDR5 or something like that, a lot of designers will actually use a curvy trace. So given that that's not, a critical constraint, it's actually easier for us to let the software do kind of whatever it wants. And so what you'll see on our
Right.
site and on our blog is that our traces are kind of any angle and generally curved. So instead of following the kind of nice left to right, up down 45-degree paths, they kind of appear to go everywhere, and they will, wrap smoothly and curve around each other much more smoothly than a 45-degree angle, perhaps.
Yep. Yeah, I think that's going to be a mental shift that I will have to do
Yeah.
because it's like, but what it kind of feels like is like I probably could look at a board now, much like I can look at mid-journey images and I can look, well, the fingers have been fixed in V5, thankfully.
Yeah.
If I count 6 fingers, it's usually either Anne Boleyn or a mid-journey image. Or like faces being blurred. You start to see this artifacting. This almost
Yeah.
feels like just a short-term AI artifacting that helps to kind of showcase that it is like that, like that it is generative design, basically.
Sure. It's honestly it's a question we've been debating within the team whether or not we want to add that constraint of making the traces, octilinear. Like on the one hand, from a physics perspective, there's not really a good reason to do it. Same thing with manufacturability.
Right, right.
On the other
Yep, yep,
hand,
yep.
like I've had people ask me, are those traces even manufacturable? And
Oh, interesting.
and
Yeah,
it's like if you understand how the manufacturing works, of course they are. But if
yeah,
you're not
yeah.
used to it,
Acid.
right, yeah, like it'll etch whatever it etches, right? Like whatever the mask
Right,
isn't there for.
exactly.
We're not
Yep.
doing this with tape and stencils and razor blades
Yeah,
anymore.
right, right. What if there was like a legitimate like like there's undercutting at like older processes, there was always this problem of like undercutting, for super sharp angles and
Sure.
all of these very legitimate concerns. But like first off, process has gotten a lot better.
Yeah,
Second off, you can if there was a process constraint, you could start to feed that back into an engine as well.
that's right.
I really think it's going to be human perception is going to
Yeah,
be the number one thing in this case.
exactly. That's absolutely right. And in general, that's something I didn't mention as far as the constraint inputs, a common question that I've gotten. One of the things that we actually like to do is to define the manufacturability constraints for you where we can. So, like,
Mm,
for example,
okay.
you're maybe more used to kind of saying, oh, I'm going to pick this fab, maybe it's OshPark, maybe it's GLC PCB or advanced circuits or something. And then you go, set up your own design rules. And then as you route, Altium or whatever, we'll give you the correct traces as you go.
Yeah.
But, if we think about the compiler analogy, the same way you can kind of compile for an Intel or an AMD or whatever processor, we should be compiling for a specific manufacturer and their capabilities. So what we actually
Mm,
do is we automatically compile for currently 3 fabs at the same time. So OshPark, PCBWay, and JLC PCB. And we basically take, kind of the best constraints that each one of those can handle, which are a little bit different. And then we try to
yep.
target all of those. And then, of course, we'll present you the board that is as flexible as possible. So if we came up with a board that can be manufactured at any of those, fantastic. But if it can only be manufactured at kind of the best, kind of fab, then at least we have that to show you.
Yeah. That's interesting. As you're explaining like the availability of fabs, and I was thinking about the constraints and stuff like that, about the octolinear kind of
Hmm.
constraints. It does seem like the engine would have to try harder to do that sort of thing. So I think
Yeah.
what you do is you don't say no, you just quote them a price
Yeah.
in compute time or upcharges, whatever. But like you're saying, it could be a constraint. It just makes the solver harder, right?
Yes. Exactly.
Yeah,
Exactly. In our case,
yeah.
now
Yeah, you
there.
basically just need to like give people like a little taste.
Yeah, I
Are
like
these
that.
are these all two-layer designs right now?
No. So all the designs on our website are all 4 layers.
Great.
So actually,
Great.
one thing that we do also is we try to control the stack up. So we, at the moment,
Ah, great. Yeah.
try to do both a 2-layer design and a 4-layer design.
Hmm.
2-layer designs for us really are only showing up in much simpler boards where there's not a lot of kind of density going on.
Yeah.
But all the boards that are on the blog are all 4-layer, and we kind of automatically choose, which net is the ground net, which net is the most likely kind of like commonly used power net. So that gives you your ground plane, your power plane, and then everything else is done on the top and bottom layers. This is another thing. We were talking about some of the problems that we saw at SpaceX with board design on the really complicated boards, like think your like Starlink antenna, right? When the design is going to take 3, 4, 5 months or whatever it is, you typically start out with a conservative assumption about how many layers you're going to need, or even the size of the board,
Yeah.
because you don't want to
Right.
get to the
Right.
end and find out you made a mistake and have to go back. So this is another thing that I'm really excited for in the long term. Is like, well, if you have a computer doing it, not a human, why not try every single stack up that you could think of
Yeah. Right. Right. Right.
and
I mean,
find
it's
the
it's really
minimum?
literally the cost of compute, right? At that point, it's like there is cost. Like there's always cost to this sort of
Yeah.
thing, either time cost or whatever. But like most of the cost, I would imagine, is give it another spin, another compute cycle, that sort of thing.
That's right. That's right. And I mean, in
Yeah.
general, as a trend, right, the cost of compute is going to zero over time, right? Like if you look at kind of like, just Moore's law over the last 40 years, but now what GPUs and TPUs and, and just like more and more intelligent algorithms are
Yeah.
doing,
Hmm.
we're going from ChatGPT can only run on a giant cluster hosted by OpenAI to like literally this last week, somebody releases GPT-4 All, which can run on a local computer.
Oh wow.
And then eventually even variants that can run on like a Raspberry Pi, slowly, but
Wow.
still.
Yeah. Right. Right.
So
Right.
I
Yeah.
think that that trend's going to continue and is kind of favorable for approaches like this.
Yeah. Yeah. And I think I have been trying to control my inner urges around a lot of this stuff. Like I'm trying to keep my expectations limited. Not just
Sure.
your service. I'm saying just kind of like all of these AI things because I feel like
For sure.
there's a lot of inflated expectations in
Yeah.
the broader market space, especially in the media. But there's some really cool stuff there. I think it could help us to become better engineers, more efficient for jobs and stuff like that. It could get rid of some of the boring parts of work so we could focus on the important parts of work, stuff like that. But yeah, I think that I see this as part of my future workflow. I don't think I'll be doing every layout of a 2-layer board for like some simple connector in 10 years from now.
Exactly. Yeah. I mean, I think we're definitely at the point where like, something like a, I don't know, like a interconnect board or a bed of nails or something like that. Like, there's no reason you should be doing that by hand anymore.
Mhm. Right.
Then like you have to still have you almost have to be a little bit more of an expert to know where the line is, right? If you're a total beginner and you look at a AI generated board, you might not know that that board is not okay
Yeah. Right. Right.
because
Right.
like we just don't have a guarantee yet, right? Which is an issue. But if you kind of know, kind of like you were saying earlier, hey, if it's under 10 megahertz digital signals, like, yeah, even if there were 1,000 vias, the thing will work.
Well, so that actually comes up. So last episode, Dave and I were talking about we couldn't stop ourselves. We were talking about AI, and one of the questions I had was, how do you troubleshoot, or how do you know these things, like, or how do you gain that level of experience? Because you don't want to bifurcate and to be like, well, if in 2023 you had 10 years of experience, you're going to be great on these tools, and if not, you're just going to use them, and it's just a black box, and you're just clicking buttons, and good luck, kid. Like it's like that. How do you then kind of have rational educational models that helps people to then troubleshoot the things that are coming out of this? Because it's possible that a human needs to be in the loop for some part of it, right? some
Yeah.
some element of like, oh, it's on the bench, something's going weird. Now am I blaming a layout piece, which hopefully not, but am I blaming some element of a layout, or is it, should I be looking at a component and thinking like, oh, this op amp actually is at its rail and there's some kind of common mode thing here? Or is it actually because I'm pumping too much current and this trace couldn't handle it? So like, how do you then balance that stuff over time?
Yeah, that's a really good question. That's kind of the meat and potatoes of this problem over the next 10 years. By contrast to software, where you basically compile it and run and you kind of see what happens and you can experiment with it quickly. We don't have that luxury in hardware, right? We can't quite just like respin it and respin it and respin it 3 times a day and keep experimenting until it works.
Right. Yep. Right. Right. Right.
Like, what steps can we take? I think there's a couple of steps we can take on the kind of layout side, as quilters. So number one is to know our limitations, right? So, if we're detecting that you're trying to do something that we don't feel confident we've proven yet, we should at least let you know. And so that's kind of something we already do is we kind of state our limitations up front. And if we're seeing that you're exceeding them, we'll kind of make you aware of them.
That's great. Yeah.
The other thing I think overall, like that only tells us to when you should be concerned. It doesn't tell you how to solve it. I think ultimately, what is the job of a PCB? The job of a PCB is to faithfully execute the schematic, right? So an ideal PCB would have 0 length for all traces,
Yeah.
and
Right.
it would basically have no resistance, no inductance, no capacitance in the traces, and it would actually just do what your schematic says it should do. So every PCB is basically just an approximation of that schematic.
I've actually never thought of that before. What is the job of a PCB? That is a great question to ask. Yeah. I like that.
Yeah, yeah,
We should
yeah.
have some more often on this show.
Sure. Yeah, yeah. I mean, when you work on these things, you tend to think about it a lot. So, but the cool thing is ultimately that when you look at a PCB and you're asking that question of what is it trying to do, and basically the answer is trying to minimize all of the parasitics and all the effects that the schematic didn't model out. All of those quantifications are computable, right? So in general, you have 2 sets of physics to care about. You have the Maxwell equations and thermodynamics. For the most part, that's basically everything you're thinking about. And as far as the Maxwell equations, right, like there's plenty of solvers out there that are provably convergent, assuming you have the correct inputs,
Yes.
assuming you
Right.
have the right time step and all that stuff. Whether or not your simulations converged, and therefore you can get like S parameters on every trace, every pair of traces, so on and so forth,
Right.
and like quantify that.
Right. Which I would point out, I am not doing
That's
on
right.
my layouts.
That's right.
So that's already a value add right there. It's like, oh yeah, I should probably know more. I'm basing it on rules of thumb, like you mentioned, and just kind of experience of what has worked when I have hit the
Right.
order button. But like, I don't, I don't know how to solve Maxwell's equations, on a everyday basis, right? It's just like that's not something I have in my workflow.
Exactly. Exactly. And ditto for thermodynamics, right? Same kind of thing. Ultimately, you can compute the answer to the question, like, is this board designed sufficiently well? Like, you can quantify what are all of the different traces on here, what are their currents, their frequencies, what are the signal types, what isolation do I need between the loud stuff and the quiet stuff, so on and so forth. And as far as the Maxwell equations are concerned, basically everything is answerable if you can compute S parameters, right? Like if I took a blank board, hooked it up to a vector network analyzer, and
Mm-hmm.
measured like literally everything you could think of, you can then compare that against the schematic and see, does that meet the schematic's design tolerances? Again, ditto with thermodynamics. So that's kind of what we're aiming to do. So we actually
Mm.
have a full Maxwell equation solver built out. It works in 3 dimensions, fully general.
Wow.
And
Wow.
currently, we're going to release this pretty soon. But you can, basically drag and drop a board, and then drop some kind of imaginary ports from like an imaginary vector network analyzer. Input port, output port, and then just measure a bunch of S parameters across the frequency sweep.
That's cool.
And then what we're going to do next is, once we start venturing into high frequency traces, so thinking about like how can we support like at least a single Wi-Fi antenna, like many IoT boards would want. Let's then at the end of a design run, do a simulation on that trace and see if it has good signal integrity and good isolation, and then show you the design that has the best characteristic out of all of those.
Wow.
So I think that, like, answering your kind of question about how do we get to the point where you kind of know the PCB works, and if you had built the whole circuit, that it's really something in the schematic that's broken and not on the board. I think it's these two things. I think it's number one, getting to the point where we're actually computing the answer to every possible concern and showing you the results. And number two, I think there's some amount of just like education that can happen, right? Like,
Yeah.
I think
Totally.
that, and not just education, experimentation. I've seen so many different PCB designers like disagree on things that they thought were common practice.
Right angles.
Yeah, like right angles is an example, or like the other one of my favorites is like grounding strategies, right? Like, do you do a single point ground
Yeah.
or star
Star
ground, or
ground or
right?
yeah. Oh man, Keithley Instruments. That is star ground Keithley. That's the answer there.
Right. And genuinely, like, it's not a trivial question. And I think for most people it's, well, I worked for this senior engineer who told me this rule that I always
Yep.
follow,
Yep.
or I did this and it bit me and I switched to something else and it worked and now I always do the something else.
Yep.
And it's
Yep.
not actually some sort of like really rigorous understanding of like what the field equations are doing.
Right. Right. Nobody's like, oh yeah. So on my weekend, I was just playing, just messing around with Maxwell's equations, and I really changed my mind of my past
Right.
20 years of my career. You know.
Right. Exactly. So I think there's some of that, right? Like,
Hmm.
can we get the community together around asking some of these questions and getting scientific about it, right? Like doing
Yeah.
simulations,
Yeah.
doing measurements, trying out a bunch of things, seeing what works and what doesn't, and sharing that knowledge.
I was gonna say, my inner startup brain thing. Obviously, the number one thing to do as a startup is to come on the Amp Hour and talk to our wonderful audience. Insert applause there.
Check.
The second thing would be like, oh my god, if you hired like a visualization expert as well,
Mm,
and like you think about like the marketing value of like whoever at NASA took all of the JWST
mm,
images and then layered them with colors and like release those, but just start releasing those images of like the 3D modeling
mhm.
and like how signals propagate and stuff like that. Oh my god, just hire an artist to do that sort of stuff, and like your marketing is done. I think just be like, can your stuff do this? Because we do this we do this automatically.
Well, I mean, we have.
Yeah.
So for our simulator, we do actually publish like a 3D field for the board you uploaded. So you can zoom in, look
Oh,
around,
cool.
see the fields move around, see the E field, B field. And then like, inevitably whenever I see people do this, they're like, oh, there's the current. Does the right hand rule apply? And then they like check it and see that the curl is doing correctly. And they're like,
Yeah,
cool, that
yeah,
works.
yeah. So that is actually on your homepage with the validate with physics sim. That's
Yeah.
the
Yeah,
animated
that's
GIF you're talking
a
about.
screen capture of what the physics sim currently looks like. So once it's published,
Cool,
it should
cool,
be in a
cool.
week or two, maybe a little bit longer.
Links in the show notes for that. So quilter.ai, it's the homepage though. So we'll
Yep.
point people to that. Okay,
Perfect.
that's cool.
Yeah, I think the next step would be to pipe that into Blender and prettify it a little
Yeah,
bit. I've seen
exactly.
some people do that,
Exactly.
and
Yeah.
it looks amazing.
Oh man, yeah, exactly. And I think the other thing too is that like you said, it's almost like the kind of will it blend strategy of like let's take these two layouts for like can you upload a finished layout and put that in through the physics simulator
Yep,
as well?
exactly,
Yeah. Yeah. So like doing that side by side is, man,
exactly.
a lot of marketing stuff you can do here. So nice job on that stuff.
Appreciate it.
I I think, like unfortunately on all this stuff, like you've kind of already alluded to it. You're just fighting against convention and like I think I said this to you when we first talked, just like the grumpiest crowd of myself included. You just hardware engineers are grumpy. We're grumpy. We're
Sure,
grumpy folk, and I think proving it is good, but but I think it's just going to be a lot of skepticism.
definitely.
Again, myself included.
Yeah, I mean, no question about it. And as well, there should be, right? Like, if there's a chance that you take
Hmm.
a risk on this and it doesn't work, and then you lose 2 weeks on critical
Hmm.
path, and then Elon comes down the hall and starts
Yeah.
yelling, like, you should be skeptical, right?
If you've got Elon coming down the hall and yelling at you, you're already doing something else wrong. So just saying.
So I think that the burden of proof should definitely be on us to kind of demonstrate that this stuff works, and
Sure.
that's without question. I mean,
Yeah.
at the same time, like again, I keep alluding to this analogy of compilers because I think it's just such a good fit.
Yeah.
That was the case with compilers back in the day, right? Like it was considered autocode if
Oh,
you
really?
weren't if you weren't doing the ones and zeros by yourself. And for
Hmm.
many years people thought that it would never be possible to automatically compile code.
Uh-huh.
And even when the first compilers came out, like obviously people took them apart and they're like, wait, like let me see what's going on with this this output. And it's
Mhm.
it's not as efficient, it's not as fast, I could do it better by hand,
Yeah.
all this stuff.
That's true. Actually, one of my old coworkers, he would regularly compare assembly output
Mhm.
from a compiler to what he had handwritten, and then he would start to run comparisons as well, just to see like, oh, actually that made it. We lost a cycle on this one. And
Yep.
for certain things that actually,
Yep.
for non-critical stuff like I mean, honestly, most of the code I write, it's not. I miss a cycle, not a big deal. But like if you're in a distributed control system inside a power plant, like which I was working in, like that actually could have very detrimental
Of course.
impacts. So, yeah.
Exactly. And I think that's a wise way to approach it, right? Like, I think that even in 10 years, even in 20 years, when the software is doing extremely well, Apple is still going to hire some people to pour over the PCB design trace by trace, right? Like, there's just too
Yep.
much writing on it to not do that, right? The same way that, like, at SpaceX, people did look at the compiled output and, like, sniff it for anything that doesn't look right, of course.
Mm-hmm.
But for like 99% of designs, that's not the case. I mean, this is kind of getting at the thing that's driving me to really push on this and to make this happen. When I kind of zoom out and imagine 100-year future, like what I really want to see is that like humans are doing what we're best at, which is kind of creativity, right? Like we should be unlocking entirely new ways of doing things, right? We should be unlocking entirely new ways to approach manufacturing, entirely new capabilities fundamentally. And as soon as we've unlocked one, yeah, let's hand it to an optimization engine to use it in all the products we want to make, right? Like,
Mm-hmm.
as a kid, I got into programming when I was like, 10 years old. At that point, it was like easy to go learn HTML and make a little GeoCities website and all that nonsense. But like, that's
Classic.
cool. As a 10-year-old, you could do that. And like nowadays, 10-year-olds can like implement an AI and like ask it questions and have it generate images and websites automatically and apps and games. It's unbelievable. Where is that for hardware? Right? Like, where is the 10-year-old that can suddenly make, whatever, an iPhone competitor or a new, game controller for themselves and share it with other kids? The fact that we can't do that bothers me. Like, I think that we should minimize the latency between, kind of human creativity and like real world bits and atoms that implement that creativity.
Right. And I think especially even just in a comparative way, right? As like, if we want future engineers to be going into hardware, having other options when there are so many other shiny things, that's important, I think.
Absolutely. I mean, why you have to ask the question, why are hardware engineers so grumpy? Right? Probably they've been bit a
That's
number
a
of times by
great
hardware.
question. I don't want to ask that one. If I answer that one, I probably some deep seated stuff for myself.
Yeah, fair enough.
Yeah. I do think, yeah, I guess it is being burnt a lot, like
Yeah,
by just things that pop up and, just physics, man, just
yeah,
physics.
yeah, yeah.
So let's get into some of the nuts and bolts of this stuff. So you have this on the FAQ, but what are the how do we then how do we get this to happen for someone's like listening to this, they're 40 minutes in now, they're like, yes, I am a future quilter user.
Mm.
What does it take?
I guess I'll make a couple offers here. So, I mean, first of all, obviously, the site's up. We have a wait list. We're curating the wait list simply to actually try to work with the people that come and make sure that everything works well for them, right? So that's the easiest
Sure.
first step is just sign up for the wait list and we'll reach out, let you in and kind of work with you to see how it's going.
That's another startup question here.
Sure.
Are people more like, if they're super interested, are they more likely to be accepted if they're using a work email? Because that's the thing.
Honestly, that's not a criteria that we select for yet. I mean,
Okay.
of course, eventually, obviously, it's a startup. It's going to have to make money. Obviously, companies have the biggest
Totally.
use for this, all that stuff, right? But like, this is ultimately a deep tech problem, right? Like
Yeah.
the question isn't like if such a thing existed that was just truly excellent, would it be useful? And of course, it'd be useful. The question
Mm,
is, can you build
yeah.
it, right? So it's like selling a time
Yeah.
machine.
Yeah.
Like,
Yeah.
would you buy a time machine? Yeah, of course. But can you build it? Like, no, not so much. So
Yeah.
honestly, at this point, even if you're not at a company doing this professionally, I would still encourage you to come.
Well, what are you selecting for? I guess because like let's give the Empire audience a little advantage here. This is a primo audience, so how do we get them into your wait list? How do we get them at the top of your wait list? How do we cut
Yeah,
the line? That's what I'm really asking.
sure, sure. Honestly, two things in my opinion. So first of all, we want to make sure that you're actually intending to submit the kinds of boards that we have a chance of being able to do correctly, right? So
Aha. Yep. Great.
that's just kind of constraint number one, right? We don't want to waste your time. So think about
Yep.
boards that are, sub 2000 pins, ideally sub 1000 pins, sub 100 components,
Mm-hmm.
sub 300 megahertz signals, sub 2 amps.
Right.
That's like roughly the constraint, right?
Okay.
If you're above that, we're going to struggle and you probably won't enjoy it. The next
Yeah,
thing,
and I guess we should reiterate here too. This is basically beta testing at this point, right?
oh yeah,
Alpha testing, beta testing. I don't know. What is it?
call it whatever you like. It's early.
Gamma
Uh,
testing.
I like it. I
Yeah.
like it.
Yeah.
Right. That's the first thing. I mean, and the
Okay.
other thing that I'd love to actually do, I'd love to work more with the open source community on some of this stuff.
Mm-hmm.
So folks who are actually willing to share their design, I'd be really excited to work with,
Mm.
just to actually be able to like write a blog post about it. Right. So if there's somebody
Mm-hmm.
out there who's doing an open source design and like is geeking out on this and thinks this is cool and wants to work with it, great, come to us. Like, let's work with you and build your board. Let's prove that it works. And if we can talk about it and you can share your project, that's fantastic. Like, we
Yeah.
get to tell more
Yep.
people about what Quilter can and cannot do. So this is kind of an invitation for anybody who wants to kind of like co-build some boards with us. We'd be totally down for that. Like, we're building our own open source boards anyway. We'd much rather have somebody
Right.
who's like the actual designer of that board talking to us about, what the board's meant to do, giving us firmware and helping us understand the schematic.
Right. Right. How are you validating on the output side of things? So you mentioned you have an EE in house.
Yep.
Is it mostly because you're like you mentioned with the OpenMV board, you're replicating an existing? Obviously, you have the functionality of it, but then you also have a comparison. Is that kind of a key use case?
That's been the approach that we've taken with the boards that we've done that are on the site. So the boards that we've done
Uh-huh.
are the OpenMV, which we talked about. We did an Arduino Uno. That's kind of like the hello world of PCBs, in my opinion.
Mm-hmm.
We did a stepper motor driver, and we've done an MP3 player. And all of them were open source boards that we could just like literally buy one of and test and just see, hey, like here it is, here it works, software works. Okay,
Yeah.
cool. And then, yeah, it's just a matter of like taking that design, kind of scraping the layout, undoing the layout, putting it back in the tool. For every board on our site, we made the commitment to have no human touch anything on the board after the output. So all we do is we download it.
Oh, interesting. Okay.
We share all of our inputs and outputs so people can see. But after the input, we let the software do its thing. We download the board file. We run a DRC just to like double check that nothing else went really wrong. And that's it. And we send it straight to fab. So far, we're 4 for 4 on those designs.
Killer. Yeah, that's great. What is your expectation, I guess, of a user who's, maybe not today, right? But maybe, let's say 2 years from now, right? You've continued to find this, whatever. Do you expect that the user looks at the Gerbers or do you expect that they have built trust in the system that there's just an export to a board house?
Yeah. So we actually have a little bit of experience with this. So I obviously what I'm saying here is that I'm inviting people who are hobbyists in open source to come talk to us. Don't be afraid of doing that if you are. But we have worked with real companies that have built real boards. So I don't want to discourage people who are professionals from using this. Obviously, if you think it fits, fantastic. What we saw with some of the early users is that on the first board they do, they're very skeptical, right? So they download the board, they
Totally.
ask a lot of
Yep.
questions, not feeling too comfortable. And at that point we can even kind of I don't know, maybe even work with the customer to like build the board for them and show that it works, kind of thing, just so kind of we take the risk and not the customer, and that's fine. But after that, like after people see the first design like on their desk and working, after that people kind of just, we see people trust it a lot more on the second, third, fourth time. Those customers still ran the DRC just to like double check that nothing went wrong,
Uh-huh.
but that's it. Like I wouldn't say that they were snooping on the Gerbers really, really closely or anything. So I think, and that's valid, right? Like once you hold it in your hands and you're like, oh, this is real. It actually works. Like, huh, that's cool.
Mm-hmm.
That the
Yep.
psychology kind of starts letting you trust it.
What about kind of then the back and forth? So on the FAQ it says Altium, KiCad, and Eagle.
Mhm.
Other sites, other things maybe in the future, but like, does it spit the layout files back out as
Correct.
like a Altium layout file?
That's right. That's exactly what we do. So
Okay.
if you upload an Altium board file, then we'll spit out, a minimally modified Altium board file back, where basically we just took care of the layout parts and left everything else alone. Ditto for KiCad, ditto for Eagle. So hypothetically, I mean, speaking to your point about kind of co-piloting with this thing, you totally can, right? Like you can do a little bit of layout first yourself for the parts you really care about, upload it, let it do its thing, and then if you don't like some of what it did, go tweak it.
Yeah.
Like we're not spitting back Gerbers, or we're not forcing you to go straight to manufacturing.
Right.
It's kind of like if you had an outsourced layout person that you were emailing a board back and forth with. That's a fairly
Yep.
good model
Yep.
for how this looks.
Yeah, that's a good comparison there. Okay. Yeah, and I mean the other thing too, like being like if you don't like certain, if something really tweaks your eye with like
Mhm.
the generated layout, you could always be like, I'm just gonna bump this around, use the push and shove, whatever.
Yeah,
Clean it
exactly.
up a little bit. Yeah. I mean that's how I use Midjourney too, really. I mean like, oh, I'm gonna just remove this finger.
Yeah, 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 exactly. Yeah, and I think like I'm excited for the day where some of these generative layouts actually outperform what humans can do.
Yeah.
There's a really
Totally.
cool story with NASA. They had to design an S-band antenna around 2005 or so for a GeoSat, and basically it had to have the correct frequency for S-band, but also a certain directionality that would kind of give it the highest gain in communicating to Earth. And some of the engineers took the kind of antenna design software and threw it at a genetic algorithm. It wasn't AI. Well, that was the AI
Yeah.
of the day. And like the antenna came out
Yep.
with really weird. Like you can see a picture of it on Wikipedia. It looks ridiculous. Like nothing like you'd ever expect. But on every single actual like radiated patterns test that they did, it outperformed every other kind of antenna they had in their hands for that specific use case. So I don't think we're quite there yet on the PCB side, but I'm really excited for that.
Mm-hmm. Yeah. Yeah. And you said it was a genetic algorithm. Was that the one? I
Yes.
think I've seen that one. It kind of looks like super blocky and stuff.
We might be talking about different
Maybe.
ones. The one kind of looks like
Okay.
it looks like you took like 5 individual kind of thick wires and like bent them at random angles. I can follow up with a link later if you like.
Oh, I think I found it. An automated antenna design with evolutionary algorithms.
That's it. That's got to be it.
Okay, cool. I will link that into the show notes. That is awesome.
Yeah,
there's a paper there too. Cool.
Yep.
Huh.
So the principles has been there for a while that like you can get, and this is actually more prevalent, I think, in mechanical design, where people will kind of say like, hey, we need to handle these loads from these directions, and some generative algorithm will come up with some mechanical structure that looks like almost like a rib cage or some bones or something like that.
Yeah,
that like
right.
have the best strength to mass ratio. I want to see that in PCB design.
That would be cool. What about the so you mentioned the obviously a larger amount of space will make for a easier solving solved solution. What is there any guidance on that sort of thing? I mean, like right now, do I also upload like an outline file, like a DXF or similar?
Yeah, so the way we handle outlines is that we parse them from your board file. So, obviously Altium, Eagle, and KiCad have their own ways of defining it, a cutout, so to speak, but that's what we parse. So, in KiCad, the same way that, if you're most familiar with KiCad, there's a specific layer for cuts, and you drop a rectangle or a bunch of line segments or whatever, and like that's what we'll use. Now, the question about densities is a good one. What we tend to do with our designs is submit a few different sizes.
Okay.
So we'll
Yeah.
submit a small one, a medium one, a large one, and just like have them run at the same time, see which one comes back. We've
Mhm.
debated adding this to the tool where we basically like, if we can't meet the constraints you set, we automatically relax it a little bit and kind of like go bigger and bigger on the
Oh,
board
interesting.
size. That could be
Yeah.
interesting. Though honestly, the feedback we've gotten is that it would be better to increase the number of layers rather than the
Yep.
size. Because then
Yep.
at least you can usually still fit in the same mechanical enclosure you had to, even if the manufacturing costs a little bit higher because you had to go to 6 layers instead of 4 or something like that.
Yeah. I would agree with that.
So we're trying to get that flexibility in there first. I think that would be a better feature. But in principle, why not?
Yeah. Other interesting things for me would be like when I think about like place and route type of stuff that I've
Mhm.
done a long time ago. Um, it was like, I got to 98%, but it missed timing on this section. And then maybe I could go and change something about that section. So just like a general call. And this is that Copilot kind of thing, like you've been talking about. It's like hey, human, go and make this easier, a little bit easier for me, and then try again. That
Yeah.
sort of thing. So it's not like I don't want to have to be tweaking stuff over and over and over again, but at least some pointers towards if I do have a hard constraint on size, like you said, being able to switch to more layers, being able to, do some custom piece of the layout so that it makes things easier. Moving a component that I don't care about, that
Hmm.
maybe I put down a connector, but I don't actually, like I just want to reconsider that connector.
Right.
Then that would be helpful too.
Yeah. Another cool thing we haven't done yet, but I'd like to, is things like pin swapping. A lot of these kind of test engineering boards that we do, you have like, I don't know, 30, 40, 50 signals you want to hook up to some connector. And it doesn't actually matter which one goes where. It's like that's something that would be nice for the algorithm to be able to optimize on its own as a kind of released or relaxed constraint.
Mm-hmm. Yeah.
Yeah, there's lots of different things that you could do for sure. And it's funny you say the 98% number. I think that is kind of the big difference between a good tool and a bad tool in this case. It's like it's the last 2% is by far the hardest piece.
Yeah.
So like
Yeah.
for the vast majority of boards that we do that are like at least within our scope, like yeah, like the ones that don't complete will get to 98, 99%. But man, finding a path for that last one, like that's where you've blocked yourself into a real corner. And even for a human,
Oh
man,
yeah.
it's really annoying to go back.
I'm literally thinking of I have video proof of it when I did the
Mm,
ABC board. The like I was basically just like out of room, and I think
yeah.
I think I did 20 total layout videos, and I think the last 4 were probably about the last 2%. Just like pushing
Yeah.
here, shoving there, and yeah, it's
Exactly. That's why we
that's
we
crazy.
really pride ourselves in trying to get to 100%. Like
Mm,
the baseline before even thinking about any physics or anything is 100% completion with zero DRC violations. If we didn't get
mm,
that, we consider that a failure on our part
mm.
because that last part is so hard.
Do you think this is going to sound bad? Do you think you would relax any of the physics constraints? So like, I can imagine some of my layouts probably have more crosstalk than they should.
Mhm.
However, I'm willing to risk that sometimes in order to squeeze some traces through a little tiny area when maybe the traces are closer together than they should be. But I'm willing to take that risk and kind of deal with it later. I know that sounds bad, but I have done it, and I've kind of known the risks maybe later in my career. How about
Sure, sure.
that?
Yeah, I mean, we're not at the point where we're making those trade-offs at this point. And certainly
Hmm.
if we were doing that, we would absolutely let the user know, right? And ideally numerically, to kind of
Hmm.
really show what the impact is. But the thing I'd rather us do is like relax a slightly different constraint. So for example, maybe we had to relax a crosstalk constraint on a 4-layer board, but here's a 6-layer board that does meet it. And then as the designer you can choose like, do I really think it's important to have such and such level of isolation, or am I going to go for the cheaper
Yeah.
board that's 4
Is it
layers?
cost or is it right? Yeah.
I think that'd be much better
Yeah.
than just like not even giving you an option that meets your constraints.
Yeah, I think that's those trade-offs. I mean, this is like basically describing engineering at a base level at this
Hmm.
point. It's just like you have to someone has to make these decisions. And I will bring it back again to that, how do you know, especially as a younger engineers learning this sort of stuff too. It's like I just think there's so much space for education in
Yeah.
there because and now that if you have something where you can run a A/B test effectively and say like,
Hmm.
actually, this we did the solving on it, and this trace next to this one causes 10% more crosstalk, and that's here's what the signal's going to look like, or something like that. Being able to kind of game it out before you do it, that could help to as a learning model, I feel like, as well.
Absolutely. Yeah. I mean, I think it's critical to have that feedback, right? Like, I keep coming back to software because I think it's to a large extent what we should try strive for in hardware. And the key thing about learning in software is like you can just try and fail, try and fail, try and fail, right? Like, how do you write, some new piece of code, especially as a beginner? Like, you try something, it crashes. You try something, it crashes. You try something, it does the wrong thing. You just keep doing that until suddenly you figured out how to really make it work.
Yep. Yeah.
We can't quite do that with just building boards. I mean, I think when we get to the point where like a printer can just print the board out and have it work automatically, cool. Maybe we can get to that point in reality. But until then, I think physics is our best bet, right? Like if you really have a physics simulation that can answer the whole question for you, that's the best way to kind of try and fail.
Right. I think the software model is kind of zero marginal cost to try again. And
Right.
that does not exist in hardware in any way other than simulation. So,
right.
Well, let's lean on simulation, I guess.
Yeah. It's getting lower though, right? Like the amount of time required the cost, even in dollars and in time to fab a board is drastically dropping, right? Like 10, 15 years ago, it might have been weeks and thousands of dollars. Now, you'll get a board from JLC PCB in less than a week for $50.
Sure. But there's also unstated negative externalities like e-waste that we don't really talk about all that much, but are very significant. And I think if we can do it in a simulations way that's not, I think not a lot of this stuff, but some of this stuff has been possible for a long time. But the gates around, there is simulation software, there's solvers out there, but the capabilities and the cost to do so are, there's not enough of a drive to do it in industry as a standard practice that justifies the cost. In certain places, like you've mentioned, so like some high speed scenarios and some high reliability scenarios, you're going to do that stuff because it costs a lot to make the end board, or it costs a lot to fail, or whatever. You're going to do more and more of this stuff. But it sounds like it's just kind of bringing those capabilities kind of into the more general sphere. And if for nothing else, that's a positive thing, I think.
Yeah, absolutely. Yeah, we need to get to the point where it's, drag and drop your design and get some confirmation of what's good and what's bad on it. Mm-hmm. That would be the ideal. And like you can, pull up ANSYS or, whichever other simulation softwares and do that. But like
I wasn't going to say ANSYS, but yeah, this ANSYS is really expensive.
Yeah. I mean, aside from being ridiculously expensive, it takes a long time to learn. Right? Like,
yeah, true.
By the time you learned how to do the simulation, you could have just fabbed your board and seen if it worked.
Right. Well, and like, so the other thing too, I know that I was going to ask about this stuff is like, this doesn't exist in layout programs, but why is that? Or maybe it does, and I'm just using KiCad, so it's free. So like, maybe I should probably temper my response there, but
yeah, I mean, I think to some extent it does. I think the most, I'm not an expert at this, but like the most popular one in an ECAD software, I think, is hyperlinks in Mentor Graphics. I could be misremembering that. Likewise, I haven't either, hence why I'm kind of stumbling. And I'm sure Altium has some plugins as well to approximate some of this stuff. So I think people have definitely tried. There's also a spin-off by TDK came out recently. I forget the name of that company, but they're also trying to do like upload your board to our website as a service, and we run kind of EMI tests for you automatically, which is super cool. So I think inklings of it exist, and I think it just hasn't. It's like a chicken and egg problem, right? Like it's not good and easy enough where people are used to it, and because people don't use it, I think nobody's really trying to build it.
Right. Yeah. There's no market here. Nobody uses this. Well, they don't exist yet. How could I use it? Right. Yeah.
Exactly.
Yeah.
Exactly.
Yeah. Well, standardizing some of this stuff would be great, I think.
Yeah.
Do you think there's any false signals from this stuff so again, because you're using solvers and stuff like that, and there's margins, like, again, like you said, some of this, so like, just to go back to my example of maybe subpar design on certain things, right? Like 10% margin on crosstalk might be something that's generally acceptable, but a simulator won't tolerate. Like, how do you start to feed that back in your mod? I don't know. Like, it feels like some of this stuff is going to be squishy in the real world, like where Chris is running a trace next to another trace,
Mm-hmm.
but Quilter might be like, no, that's a 0. No crosstalk allowed.
Mm.
And like, so how does that get fed back into the modeling?
Yeah, that's a good question, and I mean, it's not that we've thought a lot about this and figured this all out yet. So this is stuff that's yet to be built, really. But I think that the right way to approach it is just to do good engineering and find all of the real constraints, right? So you're really trying to, like, if you're looking at crosstalk for a trace, what you're really trying to answer is like, on the chip that I'm feeding this trace to, what's the signal going to look like, and is it too noisy or
Yeah,
not too
yeah.
noisy, right?
Right. Yeah. Can the threshold detect it when it's like a spy signal or whatever, right? Like what is the margin on all things?
Right, exactly. So if it's a common standard, you mentioned SPY or I2C or something like that, like there are well-defined kind of noise standards where if you exceed those noise thresholds, the bus is no longer guaranteed to work. Maybe it does, but like that's not really the design corner you want to be in. You want to just meet the standard. I think it gets a little bit trickier when it's a custom application. So like maybe you have, I don't know, say an ADC, and it's doing some sensor measurement for your specific application, that isn't like a standard application. I don't know, maybe like you're trying to detect earthquakes or something, right? And then like based on the physics of earthquakes, you figure out like what is the the noise floor of the ADC, and like what is the minimum signal that you need to detect, and then you've defined your kind of like maximum allowable noise. That's where the kind of design intent has to come from the designer and tell Quilter, like, this is the kind of maximum noise or the isolation that we need on this input. So I think those are the two cases, right? Like I think in some cases, just by looking at the chip and looking at the technology that that pin is using, there's a standard or some kind of information that can tell you like if it's going to work or not, communication buses or stuff like that. But to an extent, yeah, this is going to be for the designer to set. So maybe the software equivalent of this might be like, well, we need to compile this code such that it runs fast enough, right? It needs to run in under 30 seconds.
Yeah.
And like, is the compiler going to know that that's a requirement? No, it's just going to do its best. And if it's not doing well enough, you then tweak the design to make it a little bit smarter. And so like that amount of kind of collaboration with the tool is probably always going to exist.
Yeah.
At that level.
Right. Optimization levels, I guess that's size, right? But like then I guess you could dive into RTOS and like, are you making timing there?
Right.
That sort of thing too, right? So that's a kind of parallel path that you might to fit your constraints, that sort of thing.
Yeah, but I mean, in almost any project, you have some optimization variable, right? A lot of times it's cost, sometimes it's size, sometimes it's some sort of performance metric or whatever, and a lot of times, you're kind of sacrificing everything else in order to hit, to maximize that optimization metric. And so we should be able to kind of do that as well. And to a little extent, we've started doing that, right? So even on Quilter's site now, we can give you the option of a 2-layer board or 4-layer board in a lot of cases. And the trade-off there is straightforward, right? Like 4-layer board is going to be more expensive, but you're going to get definitely better, signal integrity and noise isolation on that than a 2-layer board.
Yeah. Awesome. Okay, we should wrap up here, but I have to ask about planes. Planes on a 2 or 4-layer board, I guess 4-layer board rather. Is there like a capability for planes? Like, do you define the plane yourself, and say don't touch it, or like this is just a ground plane, or is that kind of built in as a thing that you would expect on a 4-layer?
Yeah. So currently, the way that we approach it is, even if you give us a 4-layer board, we start off by just deleting everything and converting it to a 2-layer, and then we branch off into a 2-layer variant and a 4-layer variant. And so we will add the plane. We will take care of making the pour and doing all the calculations associated with that pour. We do have the ability to go around certain pours. So maybe you have some high power section on the top layer and you wanted to use a pour for it rather than traces.
Yeah. Yeah, you're like grabbing a layout from like a vendor that's like, hey, here's the best case layout for like a switcher. You just copy that into your design and say, no touchy.
Exactly. Yeah, that's totally fine. So yeah, so as far as stack up, like we'll control the stack up, but like, a pour that you controlled on like the top or bottom layer, that's fine. Like we can leave that alone.
Okay. Cool. Well, I have to ask this as well because people yell at me if I don't. Sure. What about like pricing? So, like how much is this going to cost if it is a thing that a company uses, or I'm guessing company uses. I'm guessing individuals, or let's just say company uses.
Yeah, no, of course. That's a really good question. I mean, honestly, that's something we're going to have to figure out as we go. I want us to have tiers. So like I'd love for there to be kind of a free open source tiers. Like if you're willing to open source your design and share it with folks, then like, maybe
Hmm.
to some extent you get a free version or something like that.
Sure, sure.
Obviously we'll eventually do a free trial or something like that too when we start to monetize. I want there to be a kind of like hobbyist tier, so something in the, $50 a month range, something like that. But
Hmm.
of course, there's going to have to be an enterprise tier as well. And I'm not sure. Like
Okay.
we've had
I think that's a good benchmark with like a hobbyist tier too, though, right? I mean, like that's
right.
not a small amount, but it might say, like even as a hobbyist, it might save you what, a couple more hours with your kids, a month. Like, all right, that might be worth it. Like it
Yeah.
depends on how the flow goes. Like I pay for Mid-Journey now. Like
Hmm.
that saved me, I don't know, like a bunch of money I would put on fiber for bad artwork. Now I make the bad artwork myself. So
Right.
like there is it might not be great for a student, but for a
Sure.
hobbyist who's like just wants to get some stuff done, I think that's makes sense.
Yeah, and of course, for enterprise tier, you can expect enterprise kinds of features, right? So a lot more
Yeah.
compute, no limits, sharing
Yep.
projects, but
Yep.
also like better support. With one customer, we actually did an agreement where we made a guarantee that even if we can't complete boards as the software, we'll do them by hand,
Mm-hmm.
right? And
Yep.
so kind of like because what
Yep.
the customer really cares about is layout, right? Like I think it's like people who are into like tech and AI and stuff like that geek out on that part of it, and that's great. But like really, that's not the important part. The important part is that layout gets done,
Need the board done. It
right?
needs to be like done, and it needs to be like
It needs to
proven,
work
and then I need to move on to the next thing. Please,
exactly.
please, please.
And that's how we think, right? Like we're not doing AI for AI's sake. AI is just one of the tools that we use in ultimately serving that goal of like get the board done, make sure it works, make sure the customer can bring
Yep.
it up and
Yep.
everything's okay. And so
Yep.
yeah, I mean that could be a service as well, right? Like if the software is struggling and it needs a little bit of human help, well, from the customer's perspective, you paid for a layout service, right? So
Yeah.
maybe
Right.
some amount of human loop could be acceptable there as well. So yeah, long answer is we don't actually know the pricing yet. We're gonna have to figure it out as we
Okay.
go.
All right.
But I want to make it flexible.
Yeah, I think that's great. That's great. And I think people are used to like the open source having some level of free that makes a lot of sense. And I think, like you said, people that are interested and have open source designs they're willing to help contribute at the beginning could be an interesting way to try out something new like this. So, where can people find all this stuff and follow you online?
For right now, it's just the website quilter.ai. If you go there, that'll have the wait list for the beta and any updates that we have about the tool and things that we're building. All my contact info is on there as well. And eventually, when we start doing things like social media, we'll link that there as well.
You got to lead with social media, man. You gotta,
Yeah,
no, I'm just
I mean,
kidding. When you do social media, those visualizations, I think that's all you do. You just post that. That's some good stuff.
for sure. Yeah, that'll be fun.
Yeah.
I'm looking forward
Yeah.
to that.
All right. Well, thanks so much for being on the show. I appreciate it, and I'm looking forward to seeing what Coulter pops out next.
All right. Thank you so much, Chris.